Welcome back, folks. I'm really excited because in this lesson we're going to do our last little bit of new content for the unit. We're going to talk about converting polar equations to rectangular. So just a little bit of recall. Remember, polar have r's and thetas in them. Rectangular have x's and y's. So if we're trying to convert polar to rectangular, our goal really here is to eliminate r's and thetas and replace those with x's and y's. And I'm going to say on a little note, you don't need to solve for x or solve for y. And that's going to be kind of counterintuitive because we're used to going ahead and solving for x's and y's. In order to do this, I'm going to use the exact same four identities that we used in the last video when we converted rectangular to polar, but I'm going to use them in the opposite order. So since I'm trying to replace r's and thetas with x's and y's, I know that I can replace any r squared that I see with an x squared plus a y squared. So again, same identity from the previous lesson, but backwards, because in this lesson we're going backwards. I can replace any r cosine theta with an x, because in the last video we learned that x was equal to r cosine theta. I can replace any r sine theta with a y, and I'm able to replace any tangent theta with its equivalent y over x. So again, I'm using those same exact four identities, just in a different order. All right, so looking at letter A says r equals 2. We're trying to eliminate or get rid of r's, no thetas to get rid of in this example. Well, if I look at my list of identities, I have nothing I can replace an r with. I can replace an r squared with an x squared plus y squared. So I'm going to manipulate this equation a little bit by squaring both sides and making this an r squared equals a 4. And now my r squared can be replaced with an x squared plus a y squared. And at this point I'm done because my r has been eliminated. My equation has only x squareds, x's and y's in it, and I'm done. Okay, letter D, I'm going to tackle exactly the same way. I'm going to go ahead and square both sides. So r squared equals 16. And again, that first identity says any r squared can be replaced with x squared plus y squared. So that's exactly what I'm going to do. And I end up with 16. So squaring both sides of an equation is one strategy that you can use to manipulate it to get an identity that you'd like so that you can do some replacing. All right, I'm going to move on to letter B. Letter B says theta equals 2 pi over 3. This one I think is a little bit tricky because I don't have a trig function in it. The way that I'm going to deal with that is I'm going to take the tangent of both sides. So if theta equals 2 pi over 3, then tangent of theta must equal tangent of 2 pi over 3. Why this is helpful is because my last identity says I can replace any tan theta with a y over x. And I can use my special right triangles now to determine the value of tangent of 2 pi over 3. So 2 pi over 3 is in quadrant 2. Reference angle of pi over 3. And tangent is opposite over adjacent. So negative root 3. If you want to, you can put that over 1, but you don't have to. So you can leave that as y over x equals negative root 3 over 1. You can cross multiply it if you want to solve for y. Both of those are the same thing. Either one of them is going to get you full credit. But notice that the theta has been eliminated. There wasn't an r to replace to begin with, but everything now is in terms of y and x. All right, letter C says r equals 4 times secant of theta. None of my identities over here deal with secant. So I'm going to replace that secant with 1 over cosine. And I'm going to change that and make that r equals 4 over cosine of theta. I'm going to cross multiply. And the second identity in that list tells me I can replace r cosine theta with an x. And that's exactly what I'm going to do. Thetas have been eliminated, r's have been eliminated. I'm left with just x equals 4. Oh, I like that one. I like that one a lot. Let's jump down to letter F because letter F is a lot like letter C and then it deals with a reciprocal function. So I am going to start off letter F by replacing cosecant with 1 over sine. So this becomes r equals 8 over sine theta. Cross multiply. So r times sine theta equals 8. R sine theta, I can change and make a y. So I end up at y equals 8. Love it. All right, letter E says tan squared theta equals 9. I don't have in my list a tan squared theta, but I do have a tan theta. So I'm going to go ahead and I'm going to take the square root of both sides. Reminding myself when I take the square root of 9 on the right-hand side, got to be plus or minus 3. And now tan theta, it says over here, I can replace with a y over x. And again, if I wanted to solve for y, I could solve for y by cross multiplying. But either one of those, perfectly acceptable way to solve your problem. Love this. So much fun. All right. Letter G says r equals 8 cosine theta. And I'm looking at this and saying, man, oh man, I can't replace that cosine theta with anybody. I can't replace r with anybody. Let me try what I did in the first step. I got an r squared by squaring both sides. And if I were to go and square both sides, don't write this down, I'd have r squared equals 64 cosine squared theta. So at that point, I could replace my r squared with an x squared plus a y squared, but I'd have nothing to replace the right side with. So while it's not a quote-unquote illegal move to square both sides, it's perfectly legit, it's a perfectly algebraically acceptable thing to do. In this case, it doesn't help me advance the problem any. It doesn't help me solve the problem. So while it's not technically wrong, it doesn't help get me to the right answer either. I'm still looking for an r squared on the left-hand side. So instead of squaring both sides, I'm going to see what happens if I now multiply both sides by r. So on the left, I get r squared. On the right, I get 8 times r times cosine theta. Remember, all of those terms are being multiplied together, and I can write products in any order I want. So now the r squared on the left, I can replace with an x squared plus a y squared. The r cosine theta, if I look at the second or the third, I forget which one it is, the second one in my list, I can replace any r cosine theta with an x. So this becomes x squared plus y squared equals 8x. And even though it doesn't feel like it, it's kind of counterintuitive. At this point, you're done. You've replaced all the r's and thetas. Everybody's in terms of x squared and y squared. So we're all good. All right, letter H says r equals that ugly fraction. I'm going to go ahead, I'm going to say using that same strategy, multiplying everybody by r is going to give me a kind of a hot mess on the right hand side. So again, even though it's not wrong, it's not going to help me solve the problem. So I am instead going to go ahead and put that r over 1 and cross multiply. So r times 3 sine theta minus 4 cosine theta equals the cross product in the other direction of 12. Now I'm going to go ahead and I'm going to distribute. And now I've got some things that can be replaced. I can replace r sine theta with a y and r cosine theta with an x. So this is going to become 3y minus 4x equals 12. And just like that, I've reached the finish line. Yeah, beautiful. All right, letter K is going to be a lot like that one, so I think I'm going to go tackle letter K next. Again, I'm going to put that r over 1 and cross multiply. Once I cross multiply, I'm going to go ahead and distribute. And then now that I've distributed, I can replace r sine theta with y, r cosine theta with x. So 2y minus x equals 5. So the name of this game is just find and replace. Find something that you can algebraically manipulate so that you can replace with one of those 4 identities in the box that you need to memorize. All right, this cross multiplication thing is working pretty good for me with the fractions, so why not keep at it? I'm going to do the same thing here. R times 1 plus cosine theta equals the cross product in the other direction, or r. Let me go ahead and distribute next. So r plus r cosine theta equals 1. R cosine theta I can change and make into an x. And at this problem, or at this point, I'm kind of come to a screeching halt because while I can replace that r cosine theta with an x, this r is going to be a little stubborn and a little bit difficult. I don't have anybody to replace him with. So here's how I'm going to deal with that. I'm going to solve for r by subtracting x from both sides. Not terrible, right? I'm going to utilize that strategy that I used up in letter A and in letter D where I squared both sides to obtain an r squared. So I'm going to square both sides. Notice that I wrapped that 1 minus x up in parentheses to show that I'm squaring that whole difference. And now I can replace my r squared with an x squared plus a y squared. No need to FOIL out what you have on the right. We've now replaced all the r's and thetas with x's and y's, which was our end game, our ultimate goal. We can put a ring around it and call it done. Beautiful. Good job, guys. All right, I'm going to shoot down to letter L because letter L is pretty similar to letter I. Again, I'm going to put that r over 1 and cross multiply. Distribute. R sine theta from my list of identities becomes a y. I'm going to solve for r by subtracting y from both sides. And I'm going to square both sides. Remembering to put parentheses around my 3 minus y to indicate that I'm squaring the whole thing. R squared replace with an x squared plus a y squared. And at this point, you've eliminated all the r's, you've eliminated all the thetas, you're only left with x's and y's. It's done. Love it. All right, last one for the day, letter J. I know I'm kind of skipping and jumping all over the place here. I'm going to change that cosecant to a 1 over sine. Cross multiply. Oh, this is a nice one to end with. R sine theta from our list of identities is a y. And that one ends up all nice, all solved for y. Wow. So there you have it, folks. Polar is done. What a good feeling that is. Again, if you have questions, concerns, please always feel free to reach out by email or catch up with me in Teams. Till then, thanks for your time and attention. It's appreciated more than you know. Keep working hard.